Hello, UCIe 1X 2.0 let chiplets from different vendors and nodes work together. Now we ship larger, real products with many chiplets, tighter power performance goals, and AI HPC traffic that push bandwidth and latency. The question isn't can we connect, it's can we scale? We need more bandwidth per ping, stable links as condition changes, faster bring up, and stronger in-field behavior. UCIe 3.0 tackles those needs without changing the software model. Let me show what actually changed from 2.0 to 3.0. The biggest change is speed. Let's go from 32 gigatransfer per second to 48 over 64 gigatransfer per second, which will raise bandwidth per ping on 2D, 2.5D packages. Just as important, 3.0 adds runtime recalibration, so links can tune themselves while running, and it upgrades the sideband control path with longer reach, early firmware loading, and priority messages. There's also a mode for continuous low latency streaming. All of this built on 2.0 manageability and 3D support you already used. Why did we need those upgrades in the first place? Bingo! On planar package, pings are the limit, not logic. Wind up and the initialization were taking too long, and temperature, voltage, aging drift force the big safety margins that burns power. Short control reach also restricted how we arrange chiplet and service systems. UCIe 3.0 answers with more bandwidth per ping, faster and steadier operation, and a control plane that reaches farther. With that in mind, here are the 64 gigabit per second would buy you. Think of 64 gigabit per second as the level. With the same ping, you get about twice bandwidth, or you can keep the same bandwidth with roughly half the length. Fewer length makes routing easier. Cut crosstalk, relax power network, great for memory and accelerator split out. The result is much better bandwidth density, where pings are the bottleneck. Speed helps only if the link stays healthy in the real world. Here's how 3.0 makes that work. Links don't live at room temperature forever. As temperature, supply, and aging drift, runtime recalibration adjusts setting on the fly, so error rate and power stay on the target without dropping the link. Tie this to temporary so the system can retune during the heat spike, voltage dip, or workload change. Beyond stability, 3.0 also improves how we control and service the system. Early firmware download speeds up, wind up, and reduce failure needs. Priority messages make urgent action happen quickly and predictably. With sideband reach extended to about 100 mm, you can treat control like a small service network. Star or mesh layouts, out of band debug, and monitor incident right on the package. Some paths need low latency data. 3.0 covers that too. For converter path and customer data plane, continuous transmission sends a low stream with minimal overhead. That lowers the latency, and jitter can simplify 5 DSP handshake. This is alongside PCIe CXL turning, so you can choose the best mode per load. If you are already on 2.0, here's how to move forward. Keep your 2.0 software and textbook. Upgrade the file and controller for 64 gigatransfer per second, and confirm you have runtime recal the check signal and power integrity at 64 gigatransfer per second. Loss, jitter, crosstalk, bump map, shielding, and clock data recovery, equalization choice, define sideband priority and event rules, then validate with partner and with emulation prototype across temperature, agent, and supply droop corners. When will you see the benefits first? The first win show up in AI accelerator, die-to-die fabric, and cache links, memory and I/O, the aggregation, HBM and CXL pools, and high bandwidth sensor compute tiles. Mixed-mode chiplets also gain because pings and operations, not logic, are the real limits. Let's end with a simple rule you can apply today. Here are the summarized images showing you why UCIe 3.0 is needed. UCIe 3.0 brings faster lanes and field-ready operations. If you are in the ping limited, use 64 gigatransfer per second to raise bandwidth density. If you are operation limited by wind up or drift, enable runtime recalibration, priority sideband, and early firmware flows. Start now. Pick the right IP, choose signal integrity, power integrity at 64 gigatransfer per second, set your sideband policy, and extend validation to real conditions. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback, and please share your comments down below. Lastly, please share the video link with the people who may be benefiting from it.